Let's look at the concept of big data. This is a term that gets thrown around in the industry a lot nowadays. Big data is best understood by comparing it to the normal way that data is accessed, used, processed by most corporations, groups, industries, governments, that sort of thing. I'll show you an example of that. Okay, let's say you have our company, Acme Industries, and they maintain data storage, historical records, sales records, employee records, all sorts of things, going back to when Bugs Bunny was a kid. So they have a huge collection of data. Often this data might be stored in an electronic database. We've covered these a little bit before. A database is an organized collection of data in electronic form. So let's say Acme has, say, 50 years of data. And it goes back to all the employees they had at any point in time, all of their sales, all of the actual items they had for sale at various points. It's a lot of data. Now, let's say that Acme is really trying to figure out what the next hot product is going to be that they sell. Is it just going to be the staple of an anvil, or are they going to have some like nuclear powered jet rocket? What they could do is actually use processing and analysis programs. This is computer programs. They would be able to search through all of this data for specific data points. Things like, over a decade period, which was the most popular product and what type was it and what were the demographics of the people that bought it and what was the sale price. Lots of different things can be analyzed for. This is why you make computer programs. They can process large amounts of data. So this is a typical scenario, not a typical company, we're being silly, but large companies with lots of data about their services, products, and history will need to process that data, figure out valuable intelligence out of it. And a lot of the computer programs you'll end up working on are related to this area. And here's the point. The amount of data that we're talking about here, while it sounds exceedingly large, is usually within the capability of modern computers and the software that can process that data. But what happens if the computers and the computer programs aren't up to the task? How could that be? Let's take a look at something. Let's say part of the government wanted to do the following. Analyze all auto sales for the last 110 years. Use data from every web accessible source available. And hand enter data. Oh, and worldwide. Now we're talking about amount of data that starts to boggle the mind. If you only wanted to track 10 or 15 things about each car, which would be pretty easy to do, you'd probably come up with a lot more. Make, model, year, size of the engine, who bought it, where they bought it, what the dealer was, what color, that sort of thing. You can very rapidly build up, honestly, about 50 data points for every single car. And what if you want to track multiple users over time? When I say users, I mean owners. You can tell I'm a computer programmer. So, now we're entering into a realm of big data. The basic concept of big data is working with sets of data that are so large that conventional data analysis and storage cannot handle it. I.e., the system we illustrated before for Acme Industries. They might have to pay a lot for a lot of computers to be able to process that, but it's within the realm of possibility that they could do it. When you start entering into something like this, you have to change your methodology. Sometimes that involves changing the hardware, the actual physical computers, how they operate, how fast they can operate, how they store data, how fast they can retrieve and store data. Sometimes it means changing the essential way the computer programs that work with this do their job in order to handle such incredibly large amounts of data. There's a lot of aspects to it, but they all fall under the umbrella of big data. So big data can mean hardware, it can mean software, it can mean structure of companies, it can mean structure of data collection efforts. But they're all united under the idea that you're dealing with sets of data and working with that data that goes essentially way beyond what is conventional or normal in business and even government. Now, another point about this, because big data is a relatively new term, it can get thrown around to mean a few different things other than the hardware and software and data collection efforts I just talked about. One of the things it can also be used to apply to is the result of being able to do this. Let's say this project was actually completed. What kind of valuable data could be taken out of that? The analysis results and the conclusions based on those results can also be called big data. Again, it's a wide umbrella and a very recent new development in the computer industry, but this is essentially what it covers. Now, let's go into a little bit of logistics on how you might do this. Let's say we got the previous project done, and this is all the data we collected. Every car, 110 years, 30, 40, 50 data points about each car, gigantic collection of data. You think we're going to find any one computer with a big enough storage device to put that on? No, you're not. I mean, you might conceivably make one, but it would be purpose-built only for this thing and would cost a lot of money. Instead, why don't we farm it out? Why don't we crowdsource it, if you will? What if we take 1,000 computers and we put a tiny bit of this data onto each? So now you've got 1,000 computers, each one with a tiny bit of the data. When you add up all the data, it's this. But you have a computer software program that has kept track of which tiny slice of the data here went to which computer. So if I need some of that data, I know where to go to find it. And you could have software that says, okay, now I need to analyze that data. I've got all this historical data about cars for the last 110 years. I want to figure out something about why it is that people prefer Mercedes-Benz over BMW if they were born before 1947, but after 1920 in Hoboken, New Jersey. Okay, well, now we've split up that data across 1,000 computers. So this software will maintain track of enough points of what's on each computer that when it does the analysis, it can happen within a reasonable amount of time and not take, 24 hours to come up with an answer. These are all the challenges of big data. So very often you'll find when you're looking into this area, you're dealing with specialized physical storage of data, specialized software to manage that storage, and specialized software to accomplish the processing of that data set. All of this, again, falls under the heading of big data.